Hello, welcome to GM8, which is your advanced area and length topic. So here is the contents page for your topic, and we're going to look through the objectives one by one, and I'm going to do a quick overview of each one. What I recommend you doing is to go through, and especially when I talk about prior knowledge, because this is a lot of big topics in this unit. It's higher only. Really go through the tasks in order, don't leave anything out, don't skip anything, make sure you try and do everything, because these are going to be worth high mark questions in any exams. So objective 1, to know how to apply Pythagoras Theorem in 3D. So there's some videos here for you to watch and some worksheets and some Heggerty tasks. Okay, as I said, the teachers will be checking your score, and if there are any written worksheets, we'll probably be asking to see when you come back, or asking for photos of them sent through Frog. So Pythagoras is 3D. So I've got to calculate a couple of lengths here. I need to calculate FH. So that's obviously line F to H, which is this one. Okay, so to calculate that line, we need to find this triangle using Pythagoras Theorem. Now, if you can't remember what Pythagoras Theorem is, please go back to that unit, okay? Because I'm going to be flying through it, and I'm not going to be showing you exactly how. So we've got our right angle triangle now here, so we can use Pythagoras Theorem and go 4 squared plus 10 squared, obviously equals 116. Okay, square root that answer, and so we know that FH is going to be around about 10.77. Now what I'm going to do is, when I need to use FH now, because I'm going to need it to find BH, I'm going to call it the square root of 116 because it's more accurate. Okay, so my triangle that I'm trying to find BH now goes diagonally. So to start with it, I need FH, which I've just worked out, which was the square root of 116. I know that my cuboid is 8 centimeters high, so I'll basically just use Pythagoras to find the hypotenuse on this one. So it's 8 squared plus 116, square root of 116 squared, which is 116 obviously, and then square root. So we know that BH is about 13.42. Okay. Also, it can be used in a square-based pyramid. So a square-based pyramid with sides 5 centimeters and sloping sides, a length 13, has a vertex of at O, and the midpoint of the base M is vertically below O. So we've got to calculate AM and OM, or as Mr. Williams would like to say, OM. So what we're going to do is we're going to first of all find the triangle AMO. Okay, and well, so we draw it out, we've got the 13, but we haven't got AM, so we're going to need to try and find AC first, which means I'm going to need this triangle, which is ACD. So I know it's a square-based pyramid, so I know my sides are both 5. So I go 5 squared plus 5 squared is the square root of 50, so it's going to be 7.07. And then I can go back to my triangle, because I know AM is just going to be half of AC. So I've now got my AM, and I've got my AO, and now I need to find my OM. So I'm going to go, because it's finding one of the shorter sides, we're going to go 13 squared equals 3.54 squared, which plus OM squared, which if we rearrange, it's going to be 169, take away 12.53, and then square root, which is going to be 12.51. To know how to apply the objective 2, to know how to apply trigonometry in 3D. Now it's some of exactly the same as what we've done, so it looks very similar, but generally in trig they could be asking you to find an angle. So they want us to find the value of angle CAG, so the angle CAG, which is that one there. And so we're going to do that. So first of all, we need AC. Now we've got 2 sides at the bottom there, so we're going to go back to our Pythagoras, and we're just going to go 7 squared plus 5 squared and then square root it, which is square root of 74. We're going to leave it at square root of 74 because it's more accurate than than rounding it. Okay, now we look at what sides we've got. Again, like I said with the Pythagoras, if you've forgotten how to do trig, please go back to previous shape and space units and go for it in depth. So we've got an angle, we've got the adjacent, and we've got the opposite. Okay, so if we do that, it's going to be tan. So we know it's going to be 4 divided by because it's opposite over adjacent. So it's 4 divided by the square root of 74, and then we're going to go tan to the minus 1 because we're looking for an angle, and that's going to be 24.9 degrees. Okay, so this is a cuboid to work out the angle between DCGH and line HB. So that's DCGH and that's line HB. So we want that angle there. Okay, so first things we need, we've got 6 centimeters of BC. Okay, we are going to need HC. So we're going to use Pythagoras again. 12 squared plus 8 squared, square root it. It simplifies down to 4 root 13. Now I'm just going to use that in my triangle. Again, I've got the opposite and I've got the adjacent, so it's tan. So it's going to be opposite divided by adjacent, and then tan to the minus 1, and it's going to be 22.6 degrees. It can be done in pyramids as well. So calculate ACE. So the first thing we're going to do is find the length AC and then half. So we know that it's 2 centimeters by 2 centimeters, the square base. So to find the hypotenuse, it's just 2 squared plus 2 squared and square root it. So it's basically square root of 8. And then we can use that, but we're going to halve it because we only want AM. Okay, which is obviously just the square root of 2. We know that the slanted side is 3. So to find that angle, we're going to just go sine, because we've got the hypotenuse and the opposite. So it's going to be root 2 divided by 3, and then sine to the minus 1, which is 28.126. Okay, now because we want the full angle, we've got to double it. If we want MAE, okay, now again, first of all, we are going to need to find AC, and it's 4 centimeters by 4 centimeters square base. So we're going to use Pythagoras to find the hypotenuse there. Then we're going to halve it to find AM, which is 2 root 2. And we know that the slanted side is 6. So to find that angle, it's again, we've got the hypotenuse and we've got an adjacent this time. So it's going to be the adjacent divided by the hypotenuse. And then the cosine to the minus 1, which is 61.9. As I said, I've gone through this pretty quickly. The videos are so much more detailed than what we're doing. This is just a quick overview and a quick taster. Objective 3, how to find the area of any triangle. Now, we're not talking about just going half base times perpendicular height. We're going into more advanced triangles, okay? So obviously, but make sure you do know the basics of triangles. Here's lots of videos to watch and a few exercises. But if we remember that to find the area of a triangle, it's half base times perpendicular height. If we named the sides, okay, like this. Now, 1, which is the base, we could class as sine C because it's height divided by the base. Okay, so the height could be just B sine C. So it gives us the formula. Now, to be honest, I always just remember the formula, which is just half AB sine C, and that finds a triangle when you might not have everything you need. Okay, so here's an example. It's a non-right angle triangle, so we can just go, okay, well, the area of the triangle is half 8 times 5 times sine of the angle between them. Okay, which is 18.1 centimeters squared. Do another example. We can do half times 11.8 times 7.6 and sine 67. Okay, it's just another way of finding a triangle when you haven't been given everything you need. Objective 4, to know how to use a sine rule to find missing angles and sides in right triangles, and to know how to identify ambiguous cases of the sine rule. So I'm just going to quick overview the sine rule. Obviously, there's a lot of tasks and stuff there, but it is worth it to go through. These are high mark questions, as I said. So if the question concerns length of angles in a triangle, you may need to use a sine or cosine rule. Now, so I've got a couple of little quick kind of like a cheat sheet to always use when going through it, and it's still something which runs through my head from when I was at school. So if it's a right angle triangle and there are no angles involved, it's Pythag. Okay. If it's a right angle triangle and there are angles involved, it's normal trigonometry, you know, sine, cos, tan, that sort of thing. Okay. If the triangle is not right angle, you'll need the sine or the cosine rule. Okay. So it's not right angled. I can see this triangle. And now in any triangle, you've got the ratio of, the proportion of A divided by sine of A is the same as B divided by the sine of B, and C divided by the sine of C. Okay. Now it can be the other way around, because obviously they're proportions, so that could be sine A over A, depending on what you're looking for. You'll see it become clear in a minute. You don't have to learn the sine or cosine rule; they're normally given to you in your exam paper. You just need to know when or how. So you can only use a sine rule if you have a matching pair. Okay, so one angle and the opposite side to it. So like these, or these, or these. Okay, and then if you have just one of a side or angle, you can use the sine rules to find any of the others. Okay, so for example, on here, I'm looking for x. I have 10 and 65, which is a matching pair, and I have 40 and I'm missing x. So is it right angle triangle? No, it's not. Is there a matching pair? Yes, there is. So it's the sine rule. So we label our angles A, B, C, and then A, B, C. So we're going to go A over sine A equals B over sine B. So we don't need the sine C bit, the formula. So we can fill in the bits that we know. So A is x that we're looking for, and it's sine A. And B is 10, and sine B is sine 65. Now if we work this out, we can do 10 divided by 65, sine 65, and then we times by sine 40, and that will give us x. So we know that x has got to be 7.09 centimeters. Okay. If we do this one, so we've got an angle this time, so we're going to have the sine rule the other way up. Okay. So is it a right angle triangle? No. Is there a matching pair? Yes, because there's 65 and 10. Use a sine rule. So label your sides and angles. We're going to have it up the other way. We're going to have sine A on the top this time. So we don't need the C bit of the formula again. So we're going to fill in the bits we know. So we know that sine of omega is going to be divided by 7.1 is the same as sine 65 and 10. So we can do that, and it gives us 0.643, yeah, and so on. Now we don't want that. We want it into an angle. So we're going to go shift sine, and that's going to give us 40.05. Next one is the cosine rule to find missing angles. Again, loads of videos, loads of tasks to do, and make sure you work yourself through them. Here's a quick overview of it. If the triangle is not right angled and there is not a matching pair, then you'll need the cosine rule. So, so here is the cosine rule. In any triangle ABC, a squared equals b squared plus c squared minus 2bc cos a. So if we look at that, and we're just basically going to substitute that in. So is it right angle triangle? No. Is there a matching pair? No. Okay. So we're going to use the cosine rule. So label the sides and angles, calling the given angle A and the missing side A. Okay, and then that's going to be B, and that's going to be C. So now we can substitute it in. So A squared is going to be B squared, which is 12 squared, plus C squared, which is 9 squared, minus 2 times 12 times 9 times cos 20. Okay, pop that into your calculator, and you'll get 22, the square root of 22.026. Okay, so it's going to be 4.69. Now, one thing I recommend when you do these is always look, does my answer look like normal? Well, first of all, there is a massive issue with that question, because I realised I've typoed the question. I've put kilometres between A and B and centimetres between A and C. So Mr. Pritchard's the nine on this one, but I'm already for a recording, so I'm not going to change that. So let's just pretend that says that kilometres says centimetres. Okay. So you can have it in worded form, but what I would advise, if you get a question like this, draw it out. So a man starts at the village of Chartham and walks 5k due south to Aylsham. He then walks another 8 kilometres on a bearing of 130 degrees to Barham. What is the direct distance between Chartham and Barham? Is it in a straight line? Okay, so we're going to draw it out. So we're going to start at Chartham, and he works 5 kilometres due south. And then he walks another 8 kilometres at a bearing of 130 to Barham. What is the direct distance between Barham and Chartham in a straight line? Okay, so again, is it right angle triangle? No. Have we got any matching pairs? No. So we're going to use the cosine rule. So we're going to substitute our ones in. Remember, the angle is A, okay, and the missing side that we want is A. and then we can label the other sides, and then we can pop them in. So it's going to be 5 squared plus 8 squared minus 2 times 5 times 8 times cos 130, which I know I'm going through this really fast, it sounds really complicated, but just take it slow, pop your substitution in, check it twice, then you could do it. And then so a squared has got to be that, a squared is 140, so square root it, and we know it's going to be 11.85 kilometers if you walked it in a straight line. And obviously make sure the units are correct, unlike my last question. Last one, so find omega. So on this one, is it right angle triangle? No. Is it a matching pair? No. Use the cosine rule. So we're going to label the sides, calling the missing angle A. So this is one with an angle. So we've got a squared plus b squared plus c squared minus 2bc cos A. So we're filling what we've got, okay, and we'll simplify it down. So we're going to then rearrange to get cos omega on its own. And then we're going to, it's not even omega, I don't know why I keep saying that, and then we're going to rearrange, so we're going to end up with that. So the cos is going to be 0.45 and so on, so we're going to go cos to the minus 1, and that's going to be 62.76. Last one, as I said, this is an absolutely massive topic, so they're all big mark questions. To find the area of a segment, okay, there's some videos and a couple of worksheets to help you, and a Hegarty task, okay. So the area of a circular segment, so obviously we know a circle is pi r squared. Now we know an area of a sector is basically the proportion of the circle we've got. Okay, so whatever angle we've got divided by 360 times pi times the radius squared. So that's a sector. Now the area of a segment is basically the sector, and then it's a triangle taken out of it. It's like imagining that you cut a slice of pie but didn't want the crust, or sort of slice of pizza. So the red bit is the segment. Now the way we do this is we go area of a sector, as I've said, is the angle divided by 360 as in the total circle, then pi r squared, and then we have the area of a triangle, which is half the radius squared sine of the angle, which is very simple, similar to how we did area of a circle, area of a triangle from earlier on in this this video. So here's a very long complicated formula for doing the area segment. It's obviously going to be the angle divided by 360 pi r squared, take away half times r squared, sine of the angle. Now be really careful with your bid mass here, that radius has to be squared each time. So let's just say find the area of a segment of a circle whose diameter is 20 centimeters and central angle is 29 degrees. So we can put our numbers in, so it's 29 over 360, and now remember the diameter was 20, so the radius is 10, so we're going to go pi times 10 squared minus a half times 10 squared sine 29. We pop that all into calculator, you're going to get 1.07 centimeters squared. Okay, as I said, go through the video for these. I've gone through loads. Now objective 8 is using all of them that you've got to do, so there are apply questions involving the sort of topics that we've done, so I want you to go through, make sure that you've had a go with them. Now these apply questions are going to be the harder questions in your paper. They are worth loads of marks, and if you can get a jump start on them now, you're going to find everything so much easier in the future. Okay, remember, if you are struggling, ask your teacher for help. Rewatch the videos if you need to. Okay, try every task, because it might just click doing the easier tasks and build you up. Make sure before you attempt the Pythag, the trig, that you're going through the basics first, even if it's just a quick reminder. Okay, good luck, stay safe.